Hello, grade 7. This is Mrs. Lopez. Today we are working on module 1, lesson 5, identifying proportional and non-proportional relationships in graphs. So before we worked with tables, and we know that proportional relationship is proportional when we have the same or constant unit rate. If it's not the same, it is not proportional. We also know that proportional relationship only works with multiplication and division. When you use addition or subtraction, it may not necessarily be proportional. Okay, so today is graphs, not just the tables. Opening exercise. Dominique sold candy bars to help raise money for her Girl Scout troop. The table shows the amount of candy she sold compared to the money she received. So we have candy bars sold 2, 4, 8, and 12. And we have the money received 3, 5, 9, and 12. Also notice that the first column is marked X, the second column is marked Y. Is the amount of candy bars sold proportional to the money Dominique received? How do you know? Okay, so we are looking for um, what depends on what. So if I sell more candy, I will receive more money. I probably want to find out how much money will each candy bar going to be. So I'm going to divide y by x, or money per candy to find that. So it'll be 3 over 2 on the first one. Next one will be 5/4. Third one will be 9/8. And the last one is 12/12. Are these fractions equivalent? Do we have the same value for all of them? No, I don't. Here I have 1 and 1/2. Here I have 1 and 1/4. Here I have 1 and 1/8. Here I have just 1. So this is not a proportional relationship because our unit rate is not the same. There is no way I can simplify that and get a constant number. So the amount of candy bars is not proportional to the money Dominique received. So I'll write not proportional because the unit rate is not constant. Because the unit rate is not constant. Exploratory challenge. So using the ratio provided, create a table that shows money received proportional to the number of candy bars sold. Plot the points in your table on the grid. Okay, so we are going to create proportional relationship. How do I do that? So I have a ratio of 3 to 2, right? I can make a proportional relationship by making equivalent fractions. So if I let's say multiply both numbers by 2, I will get 4 and 6. My ratio is going to be 6 to 4, which is 3 to 2. I can multiply both 2 and 3 by 3, and I will get, well, just let's write down here times 3, and I will get 6 and 9. So 9 over 6 is also 3 to 2 if I divide both numbers by 3, right? And I can multiply both of these by, well, I can actually make 0, 0 too, because if I don't sell any candy, I will receive no money, right? So that also can be one of our ratios here. Okay, so now we need to plot these points on the table on the grid. So let's plot 2 and 3, 2 on the x, 3 on the y. 2 is x, 3 is y. 4 and 6, 4 on the x, 6 on the y. Then we have 6 on the x, 9 on the y, and 0, 0. Okay. Um, One thing that remember I told you in lesson 1 is that ratio is the ordered pair. That's where it is. That's where we need that because each of these points is a ratio. Let's say this point right here is the ratio of 2 to 3 or 3 to 2, depending on what you want to look at, right? The ratio is 2 to 3. It's the ordered pair. It's the ratio of our quantities, money and candy bars. Okay. What if well, let's just leave it here and move on to the next one. Graph the points from the opening exercise. So these are the points here, and let's go ahead and graph them. 2 to 3, 4 and 5, 8 and 9, and 12, 12. Okay. Okay. So example 2, graph the points provided in the table below and describe the similarities and differences when comparing your graph to the graph in example 1. Okay, so let's look at 0, 6, 3, 9. So we'll be right in the middle. We'll have 6 and 12, 6 and 12 right here. We have 9 and 15 here in the middle, and 12, 18, 12, 18. Okay. What I'm going to do, I'm going to go ahead and grab a ruler and I'm going to make lines through all of them. Okay, so here is a line. I can connect all of these points. Here, I actually cannot even make a line connecting all of the points. Can you see that? I can make a line that is like this, but it will not connect to this point. The point was not going to be on the line. Okay, and if I look at the very first one that we did, we'll make this line right here. Okay. All right, so I want you to take a look at all of these 3 graphs. Let me just show here. And let's look where we have similarities, where we have differences. So similarity is between, let's say, this graph and this graph is that they both are straight lines. Differences, though, are going to be that this graph right here, the first one, starts from the 0, 0 point. This one does not reach 0, 0 point, which is called origin, right? Point 0, 0 is origin. So this graph does not reach the origin. It does not start from the origin. This one does. And this one is not even a line, right? If I connect all of these points, it will not be a line. So similarities, I can't really answer these 2 questions because it says with the example 1, and if I look at the example 1, well, actually I can. Similarities is that we have x and y, we have points, but I don't really see many similarities here. I will get back to this question because there is a something that we have not talked about yet. So let's see about the differences. Difference is a major one. Difference is that one is a line and one is not. When I connect, when we connect all the points, the graph in example 2 makes a line, and the graph in example 1 does not. Uh, okay, another thing that we need to know is how do I determine, based on all of these three graphs, how do I determine that we have a proportional relationship in the graph and which one does not have a proportional in the relationship in the graph? So if you look at the three graphs, only one of them makes a line and starts from the origin. That is, and we know that this is proportional relationship because we were uh, expected to make a proportional table, right? So the proportional table makes a line on the graph, and it starts from the origin. If it doesn't make a line or it does not start from the origin, it is not a proportional relationship. So here we can have the similarity with example 1. Similarity with example 1 is that both graphs are not represent non-proportional relationship. Both graphs represent non-proportional relationship. We need to find out the rule or write down the rule. Where can we have a proportional relationship on the graph? So I'm going to just flip this page over, and the rule is the following. In proportional relationship, the graph is represented by a straight line that starts from the origin. In proportional relationship, okay, rule number 1, graph is a line. Graph is a straight line. Second rule, line starts from the origin, which is a point 0, 0. Okay, if one of these rules is not followed, this is not a proportional relationship. Okay, so now go ahead and do the problem set and or homework. If you have questions, please message me. If you don't, I will talk to you in the next lesson.